today we're going to be talking about writing quadratic equations, and we're going to focus on 3 different types of problems. Let's start first with our vocab. Standard form, remember, is in the form of y equals ax squared plus bx plus c, where a, b, and c are all numerical values. We also had vertex form, which was y equals a, parentheses, x minus h squared plus k. And we're going to be seeing both of these in today's lesson. So the first type of problem that we're going to go over is how to write an equation from the given solutions. These problems are actually going to be working the reverse of factoring problems. So what we're going to do is we're always going to start out and we're going to label our solutions as x equals whatever the solution is. On problem number 1, it already is done for me. So it currently says x equals -2, and it says x must equal 8. So those are my 2 solutions. Now, I want to undo the solving, so I would have to move this value to the other side of the equal sign. So I'm going to do it by the inverse operation by adding 2 to both sides. That gives me x plus 2 equals 0. I'm going to do the same thing with the x equals 8. I'm going to subtract 8 from both sides, and I'm going to get x minus 8 equals 0. Now this shows me my 2 factors, so I can write this in what we call factored form, which is y equals, and my 2 factors in a set of parentheses. Now to get the final equation in standard form, I have to use my knowledge of multiplying polynomials. So that would be, you could either do the box method, or you could do FOIL, or you could even think double distribute. So I'm going to go ahead and do the double distribute right here. I'm going to say x times x gives me x squared. X times -8 gives me -8x. 2 times x gives me positive 2x. And 2 times -8 gives me -16. My last step is to combine like terms. You can see I have -8x and positive 2x. So that's going to give me a quadratic equation of y equals x squared minus 6x minus 16. And you'll see that's in standard form. All right, number 2 is a little tricky for 2 different reasons. One, it's tricky because it doesn't just say x equals, but the second thing it's tricky is because it has a fraction. And students that miss these problems typically miss them because of the fact that it has a fraction solution. So here's what this means. This right here, in other words, means that I have an ordered pair at 7, 0. Well, remember when I have y as 0, that is a solution. So I can actually rewrite this as x equals 7. Same thing over here. This right here is the same thing as an ordered pair of -2/3, 0. So in other words, my other solution is -2/3. You can think about this as if it was g of x, the 7 is my x value. The whole thing, the whole g of x is my y, because remember, f of x is the same thing as my y term. All right, so now we're going to solve this. The first solution is the exact same thing I did above. So I'm going to have to move that 7 to the other side by subtracting 7. So I have x minus 7 equals 0. For the other solution, here is where people mess up. They want to just add 2/3. That is not how we solve these. We actually have to undo both pieces. So what we're going to do first is get rid of the fraction. We're going to multiply both sides by the denominator. So multiply both sides by 3. That would give me 3x equals -2. And then I have to move the -2 to the other side by adding 2. So that gives me 3x plus 2 equals 0. If you have done this correctly, you will not have fractions in either of these factors. So if you get a fraction, that's a dead giveaway, something's wrong. All right, so I'm going to write my factored form, which is y equals, I'm going to put each factor in a set of parentheses, and then I'm going to double distribute. So I have x times 3x to get 3x squared, x times 2 to get 2x, negative 7 times 3 gives me negative 21x, and negative 7 times 2 gives me negative 14. My last step, combine those like terms. So that gives me a standard form equation of y equals 3x squared minus 19x minus 14. Okay, let's do one more of those. I'm going to take each solution and set it equal to x. They're already set up like that for me, so I'm just going to copy these down over here. Now I have to get rid of the denominator, so I'm going to multiply by 4 to both sides. That gives me 4x equals 3. Then I have to move that 3 over by subtracting. So I get my first factor as 4x minus 3. Okay, for my second fraction, I'm going to multiply both sides by 5. That gives me 5x equals negative 1. Don't forget that negative sign. I got to move the negative 1 over, so I'm going to add 1 to both sides. That gives me 5x plus 1 equals 0. Set up my factored form, so y equals my first factor of 4x minus 3 and my second factor of 5x plus 1. Remember, I should never write factored form and have a fraction in it. Now I'm ready to double distribute. 4x times 5x gives me 20x squared. 4x times 1 gives me 4x. Negative 3 times 5x is negative 15x. And negative 3 times 1 gives me negative 3. Last step, combine those like terms. So that leaves me a standard form equation of y equals 20x squared minus 11x minus 3. All right, the next type of problem we're going to deal with is we are going to write quadratic equations from the vertex and a point. And if you remember, we actually did part of this yesterday. We took information, the vertex and a point, and we put it in vertex form. So the only new part is how do I get from vertex form to standard? So I'm going to show you that first. So first thing I have to do is I have to look at this little squared. And remember, I have a binomial inside the parentheses, so I can't try to distribute that exponent. Instead, that 2 means I have 2 sets of parentheses. So I'm going to rewrite it by expanding my parentheses. So I'm going to write my x plus 5 2 times. Next, I'm going to double distribute my 2 sets of parentheses. I'm going to leave that negative 2 in the front. I'm just going to drop it down. And what I get when I double distribute, I'm going to leave in a set of parentheses. So x times x gives me x squared. X times 5 gives me 5x. 5 times x gives me 5x. And 5 times 5 gives me 25. And then I drop down my minus 3. My second step is I'm going to distribute this negative 2 that's out front to everything in the parentheses. Now you might be asking why I'm not going to combine the 5x and 5x. And really the answer is you could, but I'm going to combine like terms again later. So I just save all my combined like terms for the same step, just to save me a step. So I'm going to distribute this and I'm going to say y equals negative 2 x squared. Negative 2 times 5x gives me negative 10x, and I have 2 of those. And negative 2 times 25 gives me negative 50. Once I distribute that negative 2, the parentheses can go away because that set of parentheses is there for not only the square, but also to show me that the negative 2 is being multiplied by the parentheses. So once I take care of both the exponent and the multiplication, my parentheses can clear away. I'm going to drop down that minus 3. Now I'm going to combine all of my like terms. So I actually have two sets of like terms. I have negative 10x and negative 10x, and I also have negative 50 and negative 3. My final standard form equation would be negative 2x squared. Combine my x's and I get negative 20x. Combine my constants and I get negative 53. So now I'm going to look at one of those problems from yesterday, and I'm not going to stop at vertex form. So I'm going to take the vertex and the point, come up with vertex form, but then I'm going to take that vertex form and convert it to standard. So I kind of have two parts to this problem. First up, I'm going to find vertex form. So remember, whenever I see the word vertex, I know that that's my h and k. My other point is my x and y. I'm going to plug it into my vertex form equation. I'm just writing this down first. And I'm going to plug in what I know. Y is 30. A I do not know. X is 7 minus my h is negative 1. Remember, when I have minus a negative, that's going to turn to a plus 1. And my k is negative 2. So I just put minus 2. Now I'm ready to solve for a. Start first with parentheses. 7 plus 1 gives me 8. Now I'm ready to apply that exponent. 8 squared is 64. And remember, this is saying a times 64. So I'm going to write that 64 in front. Then I'm going to add 2 to both sides. I get 32 equals to 64a. Divide by 64. And I can write a as 1/2, or I can say 0.5. Either one's fine. Now I'm going to write my vertex form equation. So y equals my a value of 1/2, x minus my h value, which is negative 1. Remember, it's going to then change to a positive 1. Squared minus 2. Again, notice whenever I set up my vertex form equation, this part right here, you'll notice when I initially plug it in, is going to stay the same down here. It doesn't change. The only thing that changes is the y, a, and x. All right, so now I'm going to take that vertex form equation and I'm going to convert that to my standard form. So I'm rewriting it so I can start from there. Remember, that 2 tells me I expand it, so I write it twice. Now I'm going to take care of my parentheses, so I'm going to double distribute those two parentheses. I'm just going to drop down my 1/2. X times x is x squared. X times 1 is x. 1 times x is x, and 1 times 1 is 1. Make sure when you double distribute that you put that resulting answer in a set of parentheses. One of the biggest mistakes students do is they don't put those parentheses there, and so it looks like 1/2 x squared. And because they do that, they don't do the next step, which is distribute. So I have to take that 1/2 and distribute it. That's going to give me 1/2 x squared. 1/2 times x is just 1/2 x. I have 2 of them. 1/2 times 1 gives me 1/2. Drop down my minus 2. Now remember, my last step is I'm simply going to combine like terms. So I have my x's I can combine, and I have my constants I can combine. So that's going to give me a standard form equation of y equals 1/2 x squared. And if I have 1/2 x and 1/2 x, that gives me 1 whole x. And 1/2 minus 2 is going to leave me 3/2. So you can see we went from given the vertex and a point all the way through vertex form into standard. So I can do both. All right, last type of problem today is we're going to talk about quadratic regression, which is, remember, just finding the line of best fit for a quadratic function. And so we do want to write these always in standard form. You can do it with your TI-84 calculator or with Desmos, it doesn't matter which one you want to use. Your steps are going to be almost identical as when we did this with a linear function. So you're going to do your stat edit. You're going to plug your table that's given to you into L1 and L2. When you do your stat calc, this time I want to select option 5 that says Quadratic. Last time we did this, we used option 4, which was linear regression. Then we're going to calculate and we're going to write our equation, making sure we set it equal to y. All right, if you do it in Desmos, the difference here is you're going to hit that plus sign and then click on the table and input your data. Once you do this, you should see this little button appear out to the side. It looks kind of like a scatter plot. You press that, select your quadratic regression, and then copy your equation down. It's as simple as that. Now we can use this method anytime I'm given a table. I can always use it to write an equation for me. I just need to know what type of function it is, because that would change if I use linear, quadratic, or eventually exponential. All right, so I'm going to try number 1. Again, you can do either your TI-84 or your Desmos. It does not matter. If you do your TI-84, remember you're plugging this in L1 and L2. If you're doing Desmos, data would be my X and runtime would be my Y. I'm going to plug that in. If I use my TI-84, once I get all my data in, I'm going to hit stat calc and pick option 5 and then calculate. This is going to give me an equation of y equals, I'm going to round 0.51x squared plus 0.59x plus 0.16. Please double check that you are giving me a quadratic function whenever it says up here in the directions, quadratic function. What happens is a lot of students accidentally pick linear regression because they're so used to doing that before that they give me a linear equation. Make sure you're using the right type of equation. All right, so we're gonna do basically the same thing, only now you'll see I don't have a table, but I have a graph. So think about it. I can take this graph, create a table, and then I could do the exact same thing. So whenever I go to create this table, I really would like to use my vertex as long as it's a nice clean point. I don't want to use a vertex that would be a decimal ever. So this vertex is at -1, -4. So that's going to be my middle point. Then I'm going to pick 2 points on the left side and 2 points on the right side. So I'm going to pick this point, which is at -2, -3, and here, which is at -3, 0. I want to stay away from using any fractions or decimals in this table. The next one, I'm going to pick 2 to the right, so that would be at 0, -3, and at 1, 0. Then I can take my table and do the exact same thing. I can use my TI-84 or Desmos. I'm going to plug in my data. Again, if you do it in TI-84, that would be list 1, list 2. And make sure your equation is a standard form quadratic equation. We can see a parabola has to be a quadratic equation. So if I type that in my calculator, I get x squared plus 2x minus 3. Now, real quick, let's say that my vertex is not a nice clean point. I could settle for only listing 4 points in my table. I could pick 2 on the left of the vertex and 2 on the right. I, again, never want to use decimals or fractions in my table. At bare minimum, you must use a total of 3 points to be able to come up with your equation. You cannot use any less than that or your equation will not be accurate. So anywhere between 3 to 5 points for a table, and that will give you an accurate equation. Again, this method will work no matter the type of equation or graph I'm given, as long as I select the right type of regression. So if I'm given a linear equation on a graph, then I could take that, create a table of values, and do the same thing as long as I select linear regression.